Hi, Dr. Edwards here. In this video, I'm going to show you how to do grams, moles, and molecules interconversions by dimensional analysis. Dimension analysis is a process whereby common conversion factors are used to convert between units. In this diagram, we show you the relationship between grams, moles, and molecules. Moles is the common factor between grams and molecules. Grams are converted to moles and moles to grams using the molar mass, which is in units of gram per mole. Molecules are converted to moles and moles to molecules by using molecules per mole, which is Avogadro's number, 6.02 times 10 to the 23 molecules per 1 mole. So let's use this process to do an interconversion. Let's do this by using the following problem. A student collected 215 grams of carbon dioxide gas in a balloon. A. How many moles? And B. How many molecules of carbon dioxide were collected? We start with the given 215 grams of carbon dioxide. By the rules of math, we know that grams then should be on the bottom of the conversion factor. We also know that grams is related to moles. Therefore, 215 times the inverse of the molar mass gives us the number of moles. But as scientists, we don't stop with the calculator value. We proceed on to what we call the significant figure value. For the rules on how to do the significant figures, see my other videos. So, if we want to move from the calculated value to the sig figs value, we must consider the significant figures of the given. In this case, 215 has 3 significant figures. Therefore, our answer should have 3 significant figures. And therefore, we round off the calculated value to 4.88 moles. Remember, in carrying out scientific calculations, we typically round to the number of sig figs. Next, let's do the B part of this question. How many molecules of carbon dioxide are collected? We start with our given of 4.88 moles that we've already calculated. And by the rules of math, mole must be in the conversion factor on the bottom of the equation, in the denominator. And the numerator then becomes Avogadro's number, 6.02 times 10 to the 23 molecules per mole. Because we know that this is a relationship that we can use in chemistry. Therefore, we process the numbers in our calculator and we write the complete number down as 2.93776 times 10 to the 23. But again, we know that in chemistry, we round numbers to the number of significant figures. In this case, again, 4.88 has 3 significant figures, and therefore we round our calculated value for final value of 2.94 times 10 to the 23 molecules. Let's consider one other problem. A scientist collected 2.423 times 10 to the 19 molecules of nitric acid from a pond. How many grams of nitric acid were collected? We start the problem by following the rules of dimensional analysis. We write the given in molecules. Therefore, 1.204 times 10 to the 26 molecules is the given. We cross multiply the units molecules using Avogadro's number of molecules per mole. And we have an intermediate calculated value of 2 times 10 to the 2 mole. Since we will be carrying this value on, we do not have to stop and consider the sig figs just yet. Therefore, we take the moles, cross multiply moles. Moles are converted to grams using the molar mass of nitric acid, which is 63.01 grams. And we calculate this 1.2602 times 10 to the 4. However, again, as scientists, we round off to the sig figs. Therefore, our final sig fig value is 1.260 times 10 to the 4. See our other videos on how to calculate sig figs and also on how to write scientific notation.